Hello everyone. In today, I would like to help you guys solve the one of the mechanics problem. So in this problem, the topic of this problem is in the statics subject. So particularly in this one, was in the topic of the resultant moment or the moment that was uh, influenced by a certain force. So in this question, the question simply asks the moment at the point of the base of point O. So first we derive point O as here, AMO, and as the moment we want to calculate. Then, looking at this question, we see that only one force of 250 was acting on point C. So in general, if we know, for example, a certain direction that was perpendicular to the line of action, for example here, if we know that this 10D, then the moment of O will equal to 250 Newton times D. That's simple. So in this question, I plan to go into the approach of finding the distance between point C to point O in x and y axis. Okay, so I will give this as dx. I will give this one as dy. So once we know dx dy, we can know the distance d here. Okay. Okay, let's start from that. So this one, if we setting up O, point O as origin, then we will have y-axis, we would have x-axis. Then our goal is to find c coordinate of x, c, and y, c. However, to do that, we first need to determine what b, xb, and yb. Now let's start from that one. So first, bx, or the coordinate of b, can derive simply by having this distance, and then we distribute the distance here. It will be 400 times sine 60, and in the same sense, this will be 400 cos 60. Okay, let's do that. So bx equal to 400 times sine 60. Okay, then by equal to 400. In by, actually we need to take 500 millimeter and minus by the distance here, so that we can have an actual by position. Okay, so I start by 500 minus 400 cos 60. Okay, now if we use the calculator, we could know those two coordinate. So in bx will simply be 300. In bx, so in bx it should give us 346.61 millimeter, and in by it should give us 300. Okay, so now we know the coordinate of bx and by. Now we will start to find the coordinate of cx and cy. So cx, if we start from b, point b here, if we know bx and by, we simply need to know the distance here, which can be found if we are knowing the angle here. For example, angle alpha, we just take 300 millimeter and cos alpha. We should know this horizontal distance. Okay, I will derive the angle here as angle alpha here. So how do we determine that angle? First, we see what the question gives us. So 60 degrees of this is provided. We know that in this sense, the light green color and the blue color giving us 60 degrees Celsius of the angle here. Okay, since these two are perpendicular, this one and also this one, meaning that if the angle here was rotated 20 degrees, this should give us also 20. Then we say that this one here is 20 degrees. Okay, So we work our way to get the alpha by knowing this angle. So this one keep at 60, right? And perpendicularly, this should be 30. Then this angle here is 30 degrees. Okay. In the same sense, perpendicular here and here. It should be 90, right? This angle 20. This angle 20 times alpha plus 30 should give us 90. Then 90 equal to 20 plus alpha plus 30 degrees. Then alpha equal to 40 degrees. Okay, now we know the angle alpha. That should make this calculation a little bit more easier. So that means the distance that will reach to C in the horizontal axis should be 300 cos 40, and then in vertical axis should be 300 sine 40. Okay, we will use that to calculate our Cx. So Cx first be based on the b value, so Cx equal to bx plus 300, let me see, 300 cos 40, and then cy equal to by plus 300 and sine 40 should give us around 576.42 millimeter, and then this should give us 492.83 millimeter. Okay, then once we know those two, we could easily determine the moment that was influenced by this force. First, if we know this direction, which is our Cx, then we multiply by the 250 times cos, let's say beta, cos beta. In the same sense, if we know the vertical axis with the same angle beta, 250 times sine beta times the cy dimension, and should give us the moment, the total moment. So first, let's see what angle beta is. So in this angle, we know that alpha equal to 40, so this should give us 50. In the same sense, this should give us 40, or the same as alpha. Now, the total moment will be derived as shown here. So m0 or mo equal to cx times fy plus cy times fx. So plug in the value here, mo equal to cx 576.42 times 250 sine 40. Oh, sorry, cos 40. Because the 250 here, cos 40, but this should give us fy, and this should give us fx. Okay. Okay. Plus 492.83 times 250 times sine 40. This should give us. Okay, then you get answer of 189.58 in the positive counterclockwise direction. Why do we know it's positive counterclockwise? It's because if this force acting in such manner here, it will rotate in this one, which if for the according to the right hand rule, this will give us counterclockwise direction. And let's conclude the solution of this question. So I hope you understand the way to solve this problem, or the approach I try to present to you. So there will be another way to solve this also. In the same question, if we have so if we use the force the couple moment, the force couple moment, we will slowly move the force from here to here. Then we got one moment, then again move to here, we've got another moment. Then we calculate those moments and then combine it into MO. That should be also. Anyway, I hope you got some help with this problem today after watching this video, and thank you for watching. We'll see you in the next mechanics problem.